All right, here is question 81 from chapter 12. This is a question this is a determination of molar mass from or a molecular weight from a freezing point depression. It's actually it's very common usage of the freezing depression. So we're given a couple piece of information here. So we know the mass of the mystery species is 17.5 grams. We know it's non-electrolyte. That just means that we're not going to need we don't need the Van 't Hoff factor in the expression. We know that this is in 100.0 grams of water, right? And we know that it was found to have a freezing point. Right, so a freezing point. This is the impure version. That's what the upper index is showing here. Was negative 1.8 degrees Celsius. Okay, and that is enough to do it. Well, actually, no, that's not true. That's not enough to do it. You also need a KF value, which you would be provided, and you'd be provided for an exam and such. But I dug out of the textbook. This is 1.86 degrees Celsius degrees Celsius kilogram per mole. Okay, let's make this happen. So first we're going to set this up to solve for the molality. If you remember this formula, this is the change in your freezing temperature is equal to the product of molality and your KF value. You would also have I in here if you were dealing with an electrolyte, but we're told that we're not. Okay, so to solve for this, we're just going to divide our difference in freezing points by the KF factor here, and solve for molality that way. So we know that water typically freezes at 0 degrees Celsius, right? From which we are subtracting minus 1.8. Right, and that's all degrees Celsius. We're dividing this whole expression out by KF, which is 1.86. Degrees Celsius, cancels that. Kilogram per mole, right, which returns us a value in moles per kilogram, which is what we want, and we find a molality of 0.967. Confident to 2 in this case because of that factor there. Right, moles per kilogram. Okay, so now we've only to extract our molar mass out of this, and then we're all set. So we're gonna write the expression for molality here. So we have the moles of the solute, which I guess in this case is just going to be the moles of X, divided by the mass of H2O. Oops. Divided by mass of H2O. Right. And we've got values in every which direction for this, except for the except for the one that we really want. So we can split this up this way. We can do the mass of X over molar mass. This is usually the way that you see it done. And we'll divide that by the mass of the solvent again. So mass of H2O. We can solve this. We can substitute this, divide everything out by B and multiply by the molar mass, and it rearranges as such. So we end up with the mass of X, which is 17.5 grams. 5 grams is divided by how much do we have? This is in 100 grams of H2O. It's got to be in kilograms, mind you, because of the moles per kilogram unit here, right? So that 100 grams we're going to write as 0.1 kilograms. And that has to be multiplied by the molality, which was 0.967 moles per kilogram. And you see we're going to cancel our kilograms, and we're going to have grams per mole as the units, which is exactly what we're after here. And I calculate a figure of 180 grams per mole in this case. And again, we're confident to the second digit here because of our impure freezing temperature. All right, that is molar mass with the freezing point depression formula.